Region y greater than equal to 0 consists of dielectric medium, and the region y less than 0 is a conductor for the surface charge of 4 nanocoulomb per meter square on the conductor, and epsilon r is equal to 3 for the dielectric medium. Then find E bar and D bar at these 2 points M and N, M at 4 minus 2 1 and N at minus 3 1 4. So this figure shows the boundary. So this boundary condition. So the first one is at point M. At point M, 4 minus 2 1. Now point M is in conductor. Point M is in conductor. This problem was asked in university. Conductor, and charges are not present. Charges are not present inside the conductor. So E bar is equal to 0 and D bar is equal to 0. Now the second is at point N, that is minus 3 1 and 4. So this point is in dielectric as shown in figure. Here it is dielectric. We write here dielectric, epsilon r1 is equal to 3, and it is conductor, S is equal to 4 nanocoulomb per meter square. So point N, this point is in dielectric, so S is equal to 4 nanocoulomb per square is on conductor. Thus S is equal to 4 nanocoulomb per meter square. Now dielectric is defined for the region. We write here dielectric is defined for the region y greater than equal to 0. So direction of dn is along positive y-axis, Therefore d bar is equal to 4 ay bar nanocoulomb per meter square. Now what is d bar? Now d bar is equal to epsilon 0 epsilon r e bar. So we can write this equation as E bar is equal to E bar divided by epsilon 0 epsilon r. It is 4 into 10 raised to minus 9 ay bar. Into 3. So it is 150.59 ay bar volt per meter. Now the next problem asked university exam for 6 marks. Given E bar is equal to 60 ax bar plus 20 ay bar minus 30 az bar volt per meter at a point on the interface between air and conducting surface. Find d bar and rho s at that point. Now what is given? Given is E bar is equal to 60 ax bar plus 20 ay bar minus 30 az bar volt per meter. Now we write here interface is between air and conductor. So d bar is equal to epsilon 0 E bar 8.85 into 10 raised to minus 12 into 60 ax square plus 20 ay bar minus 30 az bar. So d bar is equal to 531.24 ax bar plus 177.08 ay bar minus 265.62 coulomb per meter square. Now what is rho s? It is equal to dn bar. So in this case dn bar is equal to mod of, so it is square root of 531.24 into 10 raised to minus 12 square plus 08 into 10 raised to minus 12 plus 65 into 10 raised to minus 12. So by solving it on calci we get the answer 619.70 picocoulomb per meter square. Next problem based on capacitance. So asked in university exam. So for a parallel plate capacitor, area of the plate A 120 cm square, spacing between the plate D is 5 mm, separated by dielectric of epsilon r 12, connected to 40 volt battery. Then find capacitance E, D and energy stored in capacitor. So first is capacitance for parallel plate capacitor. It is C is equal to epsilon E by D. So C is equal to epsilon 0 epsilon r A by D. It is 8.85 into 10 raised to minus 12. Epsilon r is 12. Area is 120 into 10 raised to divided by D 5 into 10 raised to minus 3. So the answer of this is 255 picofarad. Next is we have to find E. Now we have C is equal to Q by V. So Q is equal to C into V. So Q is equal to 255 into 10 raised to minus 12, as it is picofarad, so it is 10 raised to minus 12. So it is 10.2 nano coulomb, value of Q. Now E is equal to V by D. What is V? It is 40. D is distance, so it is 10 raised to minus 3. So it is 8 kilovolt per meter. Now D is equal to epsilon E. This is epsilon 0. Epsilon means epsilon 0 epsilon r into E. Now it is 8.85 into 10 raised to minus 12 into 12 into 8 into 10 raised to 3. So value of D is 849.98 nano coulomb per meter square. So this is the value of D. This is third one, value of D. And the next is energy stored. So stored energy is given by WE is equal to 1 by 2 CV square. So it is C is 255 into 10 raised to minus 12 into 40 square. So it is 204 nano joule. Next problem two semi-infinite conducting plane at phi equal to 0 and pi by 6 are separated by an infinitesimal insulating gap, which is shown in the figure. So if V of phi is equal to 0 and pi by 6 equal to 100 volt, so calculate V and E bar in the region between the planes. So the first is step 1. So step 1 is calculation of V. Now we have Laplace equation in cylindrical coordinate system as delta square V is equal to 1 by R d by dr of R dV by dr plus 1 by R square d square V by d phi square plus d square Y by dz square equal to 0. This is equation 1. This is Laplace equation in cylindrical coordinate system. Now we write here voltage is function of phi only, that is d by dr and d by dz are 0. So equation is 1 by R square into d square V by d phi square is equal to 0. So we can also write equation this like it is equal to 0. This is equation 2. Now to find the value of V, integrate equation 2. So is equal to C1. What is C1? C1 is constant of integration. This is equation 3. So we can write this equation as it is equal to C1 d phi. This is equation 4. Now again integrate equation 4. So by integrating equation 4 we can write V is equal to C1 phi plus C2. Now we write here to calculate C1 and C2, apply boundary conditions. So what is given? Given is V is equal to 0 where phi is equal to 0. So C2 is equal to 0. This is equation 6. Similarly, given condition is when V is equal to V0, phi is equal to phi 0. So equation 5 becomes V0 is equal to C1 phi 0 plus 0. So what is C1 is equal to V0 by phi 0. It is equation 7. Now next is put equation 6 and 7 in 5. So it will be V is equal to V0 by phi 0. So this is the equation of voltage. We write here this is equation of voltage. Now what is step 2? Step 2 is calculation of E bar. Calculation of E bar. So we have E bar is equal to minus delta into V bar. So E bar is equal to minus of dr AR bar plus 1 by R E phi bar plus cylindrical coordinate system. So in this case, voltage is function of phi coordinate. So E bar is equal to minus 1 by R dV by d phi V A phi bar. This is equation 9, I think. Now put equation 8 in equation 9. So we get E bar is equal to minus 1 by R d by d phi of V0 by A phi bar. But phi 0 is equal to pi by 6. It is given. So we can write E bar is equal to 1 by R minus 1 by R d by d phi V0 by pi by 6 . So E bar is equal to minus 6V by pi R into d phi of now. But what is given condition? Given condition is V0 is equal to 100 at pi by 6. So E bar is equal to minus 600 by pi R. Substitute this V value and per meter. This is the equation of electric field. Next problem, a metallic sphere of radius 10 cm has surface charge density of 10 nanocoulomb per meter square. Then calculate electric energy stored in the system. So in the case of sphere, electric field intensity is given by E bar is equal to Q by 4 pi epsilon 0 R square A R bar. Now the total charge, we write here total charge of sphere. The total charge of sphere Q is equal to surface charge density rho S into surface area of sphere. That is S. So Q is equal to rho S into S 4 pi R square. So it is 10 into 10 raised to minus 9 into 4 pi into 10 into 10 raised to minus 2 square. So it is 1.257 nanocoulomb. So E bar is equal to 1.257 nano means 10 raised to minus 9 divided by 4 pi into 8.85 into 10 raised to minus 12 into R square A R bar. So this value is 11.2975 by R square A R bar. This is the value of E bar. Now we can write the magnitude. E bar is equal to 11.2975 by R square. Now energy stored, we have to find the energy stored is given by, it is equal to integration epsilon 0 E square dV. Now what is dV here? dV is equal to R square sine theta dr d theta d phi. It is in spherical coordinate system. So energy stored is given by, it is 1 by 2 epsilon 0 is constant into 11.2975 square integration of V 1 by R raised to 4 R square sine theta So next is 1 by 2 epsilon 0 value of r goes from 0.1 to infinity 1 by r dr into theta goes from 0 to pi sin theta d theta, and d phi goes from 0 to pi d phi. So this is the charge density in outer surface of the sphere. So it is 1 by 2 epsilon 0 11.2975 square, taking the integration (0.1 to infinity minus cos of theta 0 to pi, and it is 2 pi. So this is a solving answer is 71 nanojoule. This is. Thank you.